Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to work over here on the Stoker engine project finally. Been kind of at a little bit of a roadblock. If you've been following along with the project, you'd realize that we had some issues with the bronze bearings that connect the connecting rods to the crankshaft. They were pretty much right at the level of inspection where they were out of tolerance according to my book that I've got on this. So to fix the problem, we're going to make some new bearings. And I ended up having to get some bronze bearings cast. I could have done it out of a piece of solid, but it was just going to be so much more expensive to buy the material and so much waste that having a piece cast was just going to end up being a little bit cheaper for us. So that's what we opted to do, or what I opted to do. Made a pattern. I sent these over to Windy Hill Foundry, which is my foundry that I work with, and they were able to pour these out of some bearing bronze that we salvaged out of some old railroad equipment. So it's actually some bronze bearings that were on some locomotives at one point in time. And anyway, that's the material that was used. So it is bearing bronze, and we've got the castings that need to be machined. And we're going to get started on that today. So let me kind of zoom in here, show you what we got. And we're going to get started on this. At least, we're not going to get finished today, I don't think, but we're going to at least get started on getting these machined out. Let me show you what we got. So these are the originals. These are two-piece bearings. One half goes in one side, one half the other side of the connecting rods. I will machine them out of a piece of solid, and we'll cut them in half at the last step. You want to have a gap in here anyway, so it'll be fine to actually, when these wear, they're going to tighten up, so you want to have a little bit of a gap between the two bearings, so it'll be fine to just cut these in half. No need to have to make the two halves separately. It'll be a lot easier to make them out of one casting, which is what we've got right here. You can see a lot of machining that's going to have to go onto them. These are my castings that I got back. Got one little small issue here with this one. It looks like the core broke in the mold or something, and we got some material in the middle. It's just a little thin layer. I'm going to have to take this over to the drill and kind of drill that out to get started. We will eventually bore that out. But in fact, I think that's going to be the first step, is to just kind of get this hole opened up. We're going to get my boring bar down in there to bore that out. And then the next step is we're going to take this over to the milling machine. And I'm going to get these decked off, the top and the bottom parallel to one another to the proper thickness, and I'll have to measure that. I can't remember what it is off the top of my head, but we'll figure that out here in a little bit. But first, I'm going to head over to the radial drill, and again, this one here got a little flashing down there. It's just a little thin layer, but I'm going to get that drilled out before we get started any further. To drill these, I'm just going to be over here at the radial drill, and I just want to get a hole through there. Just nothing precision, alignment, this is all going to be bored out later on. I just need to get kind of something through, going down through there. So we're just going to get kind of close to center, and I'm not even going to drill it to the full size. I just need to open it up. So let's kind of get this roughly in the middle there. And that's pretty close. I'm going to start with just a pilot hole, and then I'm going to go to a bigger drill to open it on up the rest of the way. Again, just a 1/2-inch drill bit here. Just want to get a hole kind of started in here. And that's all it took to get through. It's just a little thin layer in there. And I'm going to put a bigger drill bit in there now and just go ahead and drill it on out the rest of the way. Take this drill bit out. I'm going to drop that down and knock my chuck out. This is on a number 5 Morse taper. And I've got a big taper shank drill bit here with a number 5. Can't remember what size that is, but it's smaller than the hole that it's going in there, but close to it. So we'll go ahead now and just drill that on through the rest of the way. Kind of get it started. That bottom's not very even. go. Not exactly what I was shooting for, but we got it through anyway. Now let me see if I can get that off. Yeah, no problem. All right, that'll work. I just got a hole drilled through there and we'll bore it the rest of the way out. Again, nothing precision, I just need to get that opened up. So to mill the faces of this, I'm over at the Kearney Tracker Model 3H horizontal milling machine. I've got my universal head on here with a nice big face mill on it that we should be able to just go across that in a single pass and clean it up. I'm doing this over on the K&T. I mean, I could do this on my vertical mill, but this K&T, like I've talked about before, it's just a lot more of a stout, sturdy machine, and just tends to handle these bigger, heavier cuts than the vertical mill does. So I like using it when I can. And I already had the universal head more or less set up over here. It was already mounted on the machine, so it was kind of a no-brainer just to come over here and do it this way. Now I've got my vise up here on here, and we've got our piece in the vise. Now, because this is a rough casting, one thing I was noticing was when I was clamping it, it was wanting to kind of pull that casting around. To kind of get around that, what I do is I got one side up against the fixed jaw, but on this side I've got just a piece of wire in here. This is just some aluminum TIG brazing or TIG welding wire, and I got a piece of that in here, so it's just kind of touching on that one area. What that does is that on this face, on the movable face, instead of the vise touching in the top or bottom or whatever, you're picking a spot right in the middle where it's making contact, where it's pushing it up nice up against this back face, and that keeps it flat. You know, once the sides are machined, that's not an issue, but a rough casting, that can be an issue. But because, I mean, I got it's firmly mounted, but because it is kind of in here with this wire or whatever, it's not as strong as it would be if I was just really crammed in here. So I am going to purposely be taking some lighter cuts on this. I don't want to come in here. The machine would easily take 1/4 of an inch in a pass. Not a problem at all, but I don't want to put too much work on here and rip my part out of the vise, so I am going to just take my time and ease into it. Looked up my speed rate on this this is a 5-inch cutter on bronze, and according to my little calculator here, we're shooting for about 200 surface inches per minute, or surface feet per minute. So that's 200 feet per minute on the diameter cutting out here on here. And in order to get that with this particular cutter, I need to be around 175 RPMs. My machine has a 165 RPM, which is where we're at, and that's where we're at right there. So that should be the proper speed. As far as feeds are going to be concerned, again, I'm probably going to be a little bit on the ginger side just because of the way it's chucked up in here. I'm going to back it off a little bit. We'll put it on about 5 7/8 to start out with. That's inches per minute. So I'm just going to raise this up until it touches off on the top there. And again, I don't want to get too crazy with this. I'm going to do about a 25 thousandths depth of cut, I think. Piece of cake. Let it cut all the way across. All right. Number one is done. I'm going to go ahead and get the other casting in here. We'll do the same thing on it, and then we'll flip them over and cut them to the proper thickness. All right, just kind of clean things up here a little bit. Make sure there's nothing down in the bottom that this is sitting on. Drop our second piece in. Again, here's our wire. I think I'm going to have to take a little bit more on this one. It's not cleaning up, but that's all right. You just come on out and we'll feed up a little bit more and do it. These are rough castings, so there's no guarantee they're the same thickness. And we'll do another 25. And again, we're not cleaning up, so we have to make another pass. And again, we're not cleaning up, so we have to make another pass. So we're about ready to start on the other side here. I got the part flipped over. I want to kind of just see about where I am on the thickness here. So we are on this one at about 2-inch 975, and I'm going to 2-inch 715. So we've got, 100, 200, almost 250 thousandths to come off, almost 1/4 of an inch to come off of that. So we've got a good bit of metal to take off, so let's get in here and start doing it. I've got this sitting down flat on the bottom. Once again, I got my wire in here that is pressing against, and again, because this back side over here is not a machine surface, it's a rough casting, I kind of had to move it up and down to find where the pressure was right, where it was keeping that flat. If you have to be real careful on a rough casting, because your sides are not square and everything, that you put it in there, it may cause this to shift up or down in the vise and not be parallel on across the bottom. We want these two sides to be parallel with one another. So I got that done. We're ready to roll. Let's bring our cutter over. Touch off. And I'm barely touching right there. Like I said, we got about 250 thousandths, so I think I'm going to do about a 50 thousandths cut. Make sure that's good and tight. 10, 20, 30, 40, roughly 50 right there. All right, here we go. Again, I could probably be going a faster feed rate here, but I'm being conservative just because of my setup in the vise. I just don't want to risk pulling anything out. So I'd rather just be a little bit on the conservative side. And you can tell we're hitting on the back side, we're not hitting up front. Again, rough casting. It's not going to be perfectly flat. are at 910. We got 200 thousandths to come off of it. All right, we've got these bearings faced into the proper thickness now. I'm happy with how these turned out. Got a nice finish on both sides. However, on this bearing, I will note that there are some little inclusions in there. I believe these are just some air pockets, some gas pockets that kind of floated to the top of the mold when it was being poured. The good news is that this is not a bearing face. This is just kind of the outside of the bearing. As long as we don't have any problems on the bore, which is the side that's going to really be important, I don't think it's going to be an issue. Not ideal at all, but it looks like it's just kind of right there on the surface. And again, I think they probably just had a little bit of gas in that casting for whatever reason and had some little air bubbles up at the top. It didn't really show up on the surface of the casting, but when we took that off, it's there. But yeah, it's not worth me recasting these unless we got a problem on the bore, because again, the bore is what's important. That's the bearing surface. This isn't rubbing up against anything. It's just kind of out there. And a lot of this is actually going to be machined away before we're all said and done as well. All right, next is going to be boring these out. And I will say that my initial plan was I was going to do this on the boring, with a boring head over on the mill. But as I've been thinking about this, I'm gonna see if I can set this up on the lathe and on the 4-jaw chuck and just bore these out on the lathe. I think it'll go a lot faster, a lot easier if I can get it to set up right. I'm just gonna have to go try it out and see. I don't see why I shouldn't be able to, but we're gonna give that a shot. I've got my part over here set up on the 4-jaw chuck in the lathe, and just a couple of little things here that I want to mention on getting this set up here. So obviously, you know, my jaws are kind of whatever they are because this is not a round part. The bottom is a little bit, it's probably sticking out a little bit more on the bottom here than it is on the other side. The other sides should be theoretically about the same, but what I'm more interested in is having this thing centered up on this outside diameter of the casting. That is going to be machined later, but I want it to be where that is as uniform as possible. Now, I'm not too much worried about the bottom. I'm more worried about the 3 sides over here. So what I've done is I've just kind of got my boring bar set up in here as a reference, and on each one of my jaws, I'm coming in here and I'm measuring from the edge of the cutter to the edge of the work, and I got it set on 1 inch. I just moved my cross slide in and out until I got it set to 1 inch. So I got it 1 inch there. I got it 1 inch there. This is rough measurements, you know, this is within, you know, a tiny amount. I was just looking at a scale, but, and again, this whole outside surface is going to get machined off, but I want it to be, I want the bore to match that. I'm not worried about, this is a rough hole. I'm not worried about setting up on the hole. I'm more worried about with the outside diameter here, because that's what I got to have machined off, and I want to make sure I've got metal there when I get ready to do it. So that's what I'm setting up on here. So now, you know, when you look at the cutter in relationship to the hole, it's kind of, well, it's all right there. It's all right there. It's pretty close, but it's taking a little bit more off in the bottom than it is in the top. That's fine. We got plenty of metal to come out of there. It's going to clean up. I just want to kind of get it. I'm more worried about my hole being lined up with this radius around the outside diameter. So we're set up. I'm up flat against the chuck. We got clearance where we can run the boring bar all the way through. We shouldn't hit the chuck. The hole inside the chuck is bigger than the hole that we're going to bore. So I'm going to start, because we got all that rough in there, I've got a little bit smaller diameter boring bar so I can get up in here and kind of get that cleaned out. Once I get that cleaned out, I'll probably go to a larger diameter boring bar, but I just need to start by getting all that mess cleaned up on the inside. So we're going to start there. Let's make some chips. All right, I'm starting to hear a little bit of hitting in there, so I'm going to start boring there. I need to go back to feeds. I got it in threading mode right now. So let me just feed in a little bit. Going there till we start touching off. I'm just trying to open up that hole on the inside. Now we're getting pretty close to having that hole. We're actually cutting into the diameter on the inside now. I'm going to go ahead and let this one run through, and then we'll probably go to a bigger boring bar. All right, the idea here is the larger the diameter boring bar, the less vibration you get in there, less deflection and everything else. So now that we got that opened up good, we'll touch off again, and we'll take another 100 thousandths off the diameter. Not quite cleaned up all the way into the back yet. That's where we had that little bit of an interrupted cut going on there, but it's getting there. Let me, I'm just going to get a measurement with the calipers, just kind of get a rough idea of where we're at. All right, we're about 2.5 inches. I'm going to 2 3/4 inches. I believe we'll double check that here in just a minute, but get an exact measurement, but we're getting, I know I need to do another 100 here, so. I went and grabbed a bore micrometer. This is a 3-point bore micrometer for measuring a bore. I also just want to check the calibration on this. I know that my bearing, or the journal that this is going to go up on, is 2 3/4 inches, exactly, 2.750. I need to have in the bore of the bronze probably about between 2 and 3 thousandths of oil clearance in there. So that needs to be just about 2 or 3 thousandths oversized, and I want to make sure I got a good measurement. So the first thing I'm going to do is check the calibration of this. Again, I got a ring gauge here. This happens to be a 2 3/4 inch ring gauge, which is the same target diameter that we're going for. This just happened to be one I had in my set over there. And I'm going to take my micrometer here, put it down in here, and I'm just going to check, make sure that this mic is reading in calibration. Do that again. It's got this little, up here on the top, it's got a clutch in there. That should be the amount of pressure you want to put against it. And we will read this over, and so it looks like it might be about 2 10,000ths off within my level of tolerance that I'm dealing with here. Again, we need to be about 3 thousandths over, 2 to 3 thousandths over, so I'm not going to be too worried about that, but that's reading. The mic is close enough. If I wanted to, I could get out my wrenches and make an adjustment, but it's just, for the tolerance that I've got here, it's fine. So now I'm going to check my bore here, see where we're at. And we're about 2.60 We'll call it 2.602. I'm gonna put that in my DRO up here, my digital readout, 2.602. We're going to 2.752 or 3, somewhere along in there. So I've got roughly 150 thousandths to take out of there. So I'm gonna do another 100 thousandths pass. My game plan here is we'll go ahead and get the 100 thousandths pass. That'll leave roughly 50. I'll do another measurement just to make sure everything's good. We will then go and probably do maybe a 25 thousandths cut, a little bit lighter cut. And I like to kind of sneak up on that final diameter. These boring bars, even though we've got a pretty good beefy one here, there's still just a little bit of flex in there. If you get down to that final cut, a lot of times you make a heavy cut and then come back and I'll just go back down the same path I went. The flex might take out 2 or 3 thousandths or more, and it can kind of mess you up. So if you kind of sneak up on it, making lighter and lighter cuts, that typically will get you good results. So let's do that. All right, we're getting down kind of close to where we want to be at. We'll see where we are after this pass. We should have about 10,000 still to go. It's 2.7, 725, 730, 735, 742. 742. So I got about 10 thousandths to come out. I'm gonna do a spring pass right here. I'm not gonna move anything. I'm just gonna let it go down through there, and you can see it's cutting a very small amount. That's what I'm talking about. You get a little bit of flex in these bars. So when you get down here to the end, you wanna make real light cuts. Sneak up on that final diameter. 45. So I'm right on 750 right now. So I mean, I'm reading, when I take into account those 2 10,000ths that we noticed difference in the thing, I'm right on the money right now. So I want to make it just the least little bit bigger. So I'm gonna make a spring pass again. And let it just make another little light pass and see if that'll be enough to get us where we want to be at. I'm not moving anything. And you can see it's still cutting. It's a tiny, tiny amount, but it's still cutting. I have not moved anything since that 742 is what my DRO is reading. So again, this is the importance of doing those spring passes at the end, making really fine cuts, because you can end up going too far. I think we're going to be right about where we need to be. There's 75, 1. All right, I'm 2 thousandths over, so that's perfect. I'm going to leave it right there. Well, here we are with the castings. They have been faced to proper thickness, and they have been bored to the proper diameter. So we are well on our way in getting these done. The next step is going to be the fun part, and that's going to be milling the outside shape on this rough casting, and also cutting this channel around the inside. All that work is going to be done over on the Kearney Tracker 2D rotary head milling machine. That's going to be a really interesting and fun setup and operation in itself. And that's going to be coming up in a soon video. I'm actually getting ready to head out of town for a couple of days. By the time you guys see this, I'll be back home, but I am going to be gone for a few days. So anyway, I'm getting this wrapped up before I hit the road. But we are definitely well on the way to getting these bearings machined and ready to go back into our Stoker engine so that we can move along with that project. I will note, and we talked before about the inclusions. That's just a little where a little chip got in there on that face. But again, these are not bearing faces at all. There's nothing that comes in contact with this outside face. Inside the bore, no inclusions. So I think we're good to go. Cosmetically, the casting's not the prettiest in the world, at least on this one side. The other side looks just fine. But for some reason, it looks like they got some gas bubbles in there while it was being cast, but nothing that's going to prevent us from using this bearing. I was concerned that if we got some inclusions on the bore, that we'd have to recast this, but we're not going to. We're just going to go with it like it is. Like I said, it's just a cosmetic thing in this particular application, so nothing to worry about. All right, off to a good start. We'll get this thing finished up as soon as we can, because we need to get this Stoker engine back on track and get that thing knocked out and back up to Nashville so they can get on the locomotive here soon. Well, with that, guys, that is going to be a wrap. As always, thanks so much for watching. Please subscribe if you haven't already. Those thumbs up, those comments, they both really help out a lot with the algorithms on YouTube. Please do that if you don't mind. And also a big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships. All those are great ways to really help out around here, and put a little extra contributions coming in that really enable me to take the time to shoot these videos and bring them to you. Guys, with that, we're going to get out of here. We'll catch you on the next video. Again, as always, thanks for watching.